The entire universe burst into existence from an infinitely dense point. This incredible concept is at the heart of the Big Bang Theory, our leading explanation for how time itself started, a monumental event some 13.8 billion years ago. Imagine for a moment the universe's age in its first second, a period where conditions were so extreme, human comprehension barely grasps it. Temperatures soared to an unimaginable 10 to the 32 power Kelvin, just a tiny fraction of a second after the initial spark. Within the very first moment, elementary particles like quarks and leptons formed in an incredibly hot, dense plasma soup. The universe then expanded rapidly, a process called inflation, lasting perhaps 1/trillionth of a 1/trillionth of a 1/trillionth of a second. This rapid expansion smoothed out irregularities and stretched the nascent universe to astronomical scales. Over the next few minutes, as the cosmos cooled, protons and neutrons began to fuse, creating the first light atomic nuclei, primarily hydrogen and helium. These elements formed the building blocks for everything we see today. For hundreds of thousands of years, the universe remained a hot, opaque fog of plasma. Then, approximately 380,000 years after the Big Bang, the temperature dropped enough for electrons to combine with nuclei, forming neutral atoms, allowing light to travel freely for the first time. This release of light is what we observe today as the cosmic microwave background radiation, a faint glow permeating all of space. Our future also holds grand cosmic possibilities regarding time's ultimate end. Scientists propose several scenarios for the universe's final epoch, each with profound implications. One idea is the Big Crunch, where gravity eventually overcomes the expansion, causing the universe to contract back into an extremely hot, dense state, possibly leading to another Big Bang in an endless cycle. A second prominent theory is the Big Freeze, also known as heat death, where the universe continues to expand forever, becoming increasingly cold, dark, and empty, as stars exhaust their fuel and black holes slowly evaporate over countless trillions of years, much longer than the current age of the universe itself, until only a diffuse sea of fundamental particles remains. A third dramatic possibility is the Big Rip, driven by an accelerating dark energy that intensifies to such a degree it eventually tears apart all structures from galaxies and stars down to individual atoms within a mind-bogglingly distant future. Current astronomical observations, including data from distant supernovae and the cosmic microwave background, favor an eternally expanding universe, leaning towards the Big Freeze as the most probable outcome. The sheer scale of these cosmic narratives, from the instant of creation to the incredibly distant possibilities of its demise, stretches our imagination to its absolute limits, demanding new physics to fully grasp the ultimate nature of existence and time itself. The universe itself once fit inside a pinhead. This astonishing concept is central to understanding the Big Bang Theory, which describes the origin of our cosmos. About 13.8 billion years ago, our entire reality burst forth from an infinitely dense point. During its first second, the universe was unbelievably extreme. Temperatures soared to an unimaginable 10 to the 32 power Kelvin, just a tiny fraction of a second after the initial spark of creation. Within this very first moment, elementary particles such as quarks and leptons formed within an incredibly hot, dense plasma soup. The universe then underwent a period of extraordinarily rapid expansion, called inflation, lasting perhaps 1/trillionth of a 1/trillionth of a 1/trillionth of a second. This rapid stretching smoothed out any irregularities and expanded the nascent universe to astronomical scales. Over the next few minutes, as the immense cosmos cooled, protons and neutrons began to fuse together, creating the first light atomic nuclei, primarily consisting of hydrogen and helium, the fundamental building blocks for everything we observe. For hundreds of thousands of years following this initial formation, the universe remained a hot, opaque fog of plasma where light could not travel freely. Then, approximately 380,000 years after the initial Big Bang event, the universe had cooled enough for electrons to combine with these nuclei, forming stable, neutral atoms. This crucial event, allowed light to travel freely for the very first time across the vast expanse of space. This ancient light is what we detect as the cosmic microwave background radiation, a faint, omnipresent glow permeating all space, a snapshot of the early universe. Our journey also considers time's ultimate end. Scientists propose several mind-bending scenarios for the universe's final epoch, with profound implications. One captivating idea is the Big Crunch, where the force of gravity eventually overcomes the continuous expansion, causing the universe to contract back into an extremely hot, dense state, possibly another Big Bang in an endless cycle. A second prominent theory is the Big Freeze, also known as heat death, where the universe continues to expand forever, becoming increasingly cold, dark, and empty, as stars exhaust fuel and black holes evaporate over countless trillions of years until only fundamental particles remain. A third, dramatic possibility is the Big Rip, driven by accelerating dark energy that intensifies to tear apart all structures from galaxies, stars, down to individual atoms in a mind-bogglingly distant future. Current astronomical observations, including data from distant supernovae and cosmic microwave background radiation, suggest an eternally expanding universe. This evidence leans towards the Big Freeze as the most probable outcome. The scale of these cosmic narratives from creation to ultimate demise stretches human imagination, demanding new physics to grasp existence and time within this vast cosmos. Everything will be either squeezed or torn to infinite pieces. The universe's ultimate end involves three distinct and terrifying possibilities. First, the Big Crunch suggests gravity's immense pull will eventually win the expansion battle. In perhaps 80 billion years from now, space itself could begin to rapidly contract. Galaxies would violently collide, stars would furiously merge, and temperatures would dramatically soar to extreme levels. All matter and energy would crush into a super-hot, dense point, reminiscent of a reverse Big Bang's extreme initial state. This monumental collapse might spark another Big Bang, creating an endless cosmic cycle of birth, demise. Second, the Big Freeze or heat death means endless expansion forever. The cosmos grows progressively colder, emptier, and darker. Over countless hundreds of billions of years, stars will burn out, leaving behind white dwarfs, neutron stars, and dormant black holes. Galaxies will continue to isolate from one another, drifting apart across vast stretches of nothingness. Black holes themselves will slowly evaporate over truly immense timescales, taking 10 to the 67 power years, or even 10 to the 100 power years, through a process known as Hawking radiation. Eventually, only sparse fundamental particles will remain in a vast, cold void. All energy differences crucial for any activity will vanish, creating absolute thermodynamic equilibrium, where absolutely nothing ever happens. This bleak outcome is backed by current astronomical observations showing an accelerating expansion due to a mysterious dark energy. Distant supernovae data and the cosmic microwave background radiation strongly support this eternal stretch into oblivion. Third, the Big Rip is the most violent end. Accelerating dark energy intensifies to an unimaginable degree, tearing apart all fundamental forces. It would first dismantle entire galaxies, then break apart solar systems, ripping planets from their stars. Next, stars themselves are unmade, followed by atoms themselves being torn asunder, perhaps 60 billion years away. Even fundamental particles separate until space-time itself rips, leaving no coherent structures, just raw fundamental components violently scattered into an infinite void. These cosmic ends force us to profoundly rethink existence and physics limits.